In the lesson video we did on Friday, 5-6 day 1, it was about linear systems of equations. So that should have been something you did in Algebra 2 course. That shouldn't have been anything, new to you. So make sure that you get that done. We're going to do problems 1, 5, and 6 together of nonlinear systems of equations. Now, how can we tell that these aren't linear systems? Well, if you got some powers on there, then these systems are not linear. Now, technically, the first one here, the first equation is a parabola, and the second equation is a line. Now, a line and a parabola can meet up twice if it just cuts through the parabola. It can meet up once if it's tangent to it and hits it perfectly. But the line could be so low that maybe it just doesn't touch the parabola at all. So when we're doing these, for a linear set of equations, it's 1 point. We're looking, do they cross at 1 point or not at all? But here we have some options as to what could happen. So, that's why you have to be really careful with your algebra to find if there are any mistakes or anything funky. The first thing I do when I'm doing a system of equations like this is I kind of look at what variables are there. What's sitting there? What can I do for it? You might notice that our x's aren't a match, but our y's in this case are a perfect match there. And so one is a negative y and one is a positive y. So this is a really good function to just, put a little addition line underneath and combine the two equations together. Now, when you do that, yes, our negative y and our positive y are going to cancel out perfectly. That's great. But we're going to be left with an x squared, a negative x on the left side, and a negative 2 plus 4 or a 2 on the right side. And then you got to remember how to solve a quadratic. The most efficient way to solve a quadratic is to get it set equal to 0, and then hopefully it's a factorable quadratic. In this case, it is a factorable quadratic, minus 2 and plus 1. Now let me remind you the rules of this factorization, okay? If the back sign is negative, you know that 1 is plus and 1 is minus. You know that the middle sign kind of tells you where to sit the bigger number. We need the bigger number to be the negative. Well, 2 times 1 is 2. 2 minus 1 is the 1 in the center. To get negative 1, we need to make sure that that's negative 2. So if the back sign is negative, remember, you should have a plus minus. You're doing a subtraction to get that middle center value. And then you're going to split it up. It's a very easy split up. So x minus 2 equals 0. X plus 1 equals 0. X equals 2 or x equals negative 1. Now we're not done. We are looking for the points at which these two things intersected. So it's looking as if it's intersecting at two different points. Now remember, this tells us that y equals x plus 4 if we do a quick little rearrange. So when x is 2, that would make y equal to 2 plus 4 or 6. So that's the point 2, 6. When x is negative 1, that makes y negative 1 plus 4 or 3. That's the point negative 1, 3. So it appears as if this line cuts through the parabola in two places. Well, what's really great about Desmos is that we can graph these things very nicely, and we could look at where they intersect, and that should be the points that we just got. So, although you can't do this on the test, if we were to, if I was doing my homework at home and I wanted to make sure that I got the correct answer, you can see that we do indeed have 2 points of intersection, one at negative 1, 3, and the other at 2, 6. Okay, so your algebra and your graphical interpretation should always link up, or you did something wrong somewhere along the way. Do we have any questions about problem number 1? Okay, so there's problem number 1. Now, it's your responsibility by the end of class to do 2, 3, and 4, but I would like to jump to problems 5 and 6. Now, you may not remember all of your types of equations. If they're both squared, there's a plus between them and it's equal to a positive number. This is just a circle with radius 1. And then if one is squared and one is not, that's always a parabola. So, our parabola might hit it twice. Our parabola might hit it perfectly just once. Our parabola might, even if it's like this perfect alignment, it could possibly hit it 3 times. Or maybe it's so low or so high that it doesn't hit the circle at all. So we could have no solutions, 1 solution, 2 solutions, or 3 solutions. It all just depends upon how these 2 things line up particularly. Now, I notice that my y's are of different powers, but my x's, the only x's in the problem are x squared. So to me, using substitution, or elimination on this one is probably a good bet. If you multiply this entire equation by -2, we'll have a -2x squared in the first equation and a positive 2x squared in the second equation. So let's go ahead and do that. We get -2x squared minus 2y squared equals -2. And then we have a 2x squared. There's no y's, so I'm just going to kind of leave it separate. And then equals 2. And now you can see when we add these 2 together, our 2x squareds are eliminated, which makes life great. Because then we have 2y minus 2y squared equals 0. Now, if it wasn't a value equal to 0, because it's a quadratic, we need it equal to 0 to solve that by factoring or the quadratic formula. So it kind of worked out really nice that it was equal to 0, because now we can just factor that left side. Now that left side, both of our terms are divisible by 2y. So take that 2y as your greatest common factor and just set it out in front. When you take 2y out, you're left with 1 minus y. You can check your factorization. If you were to redistribute, you better get what's sitting on the page. So don't forget the 1. It's very easy to want to forget that 1, but we need that 1 there so that when we distribute right, we get what we have. 2y divided by 2y is indeed 1, so make sure you have that 1 there. So then we have 2 things happening. 2y could be the thing that is our 0, or 1 minus y could equal 0. And then just solve each one. This is y is 0. This is that y is equal to 1. So we got 2 points of intersection. But let's plug in 2 y values of intersection. Let's plug it in and then try to solve. Now, I think a nice place to plug them in to solve for x, either one. These are smaller numbers, they're all 1 coefficients. So you can use either equation, it will work either way. First, let's plug in a y equals 0. So we get that x squared equals 1. Now, how do we undo an x squared? How do we solve for x? Square root it. What do we always have to remember to put in front of a square root? Plus or minus. Don't forget that, or you'll lose half your solutions. So we get x equals plus or minus 1. Okay, the square root of 1 is 1. You got to put that plus or minus in front. Don't forget that, or that's going to screw up your answer. So we technically have the point 1 with 0. We also have -1 with 0. So that gives us that at a height of 0, we hit x in 2 places, +1 and -1. Now we still have to plug in a y value of 1. So let's do that. We get x squared plus 1 equals 1. So x squared equals 0. Now when you do plus or minus the square root of 0, you don't get anything but 0, because plus or minus 0 plus 0 minus 0, 0 is 0. Okay, so that is the point 0, 1. So this one actually hit in 3 places. How do we check our work? Well, if you put into your equation here, or into Desmos, x squared plus y squared equals 1. That's a circle with radius 1. The other is a parabola pointing downward, 2x squared plus 2y equals 2. And it just so happens that the way that it lines up, that we do indeed hit the circle in 3 places. So that's why that one ended up with 3 solutions. So that plus or minus will help you find those multiple solutions that happen in multiple places. Do we have any questions about number 5? Okay, one more. Let's do number 6. This again is a circle and a parabola. This is a circle with radius 6. This time our parabola is actually going to be a pointing upward one. So we might hit it twice. We might hit it 3 times. We might hit it once, or we might not hit it at all. So that's what we have to prepare for, that we could have some different scenarios that happen. Again, like the last one, we've got these x squareds appearing in both. That's the only x's, and that's a really good time to use elimination. So let's multiply up here by 2. When we multiply that top equation by 2, we get 2x squared, and I'm going to put a little space here, plus 2y squared equals 12. Negative 2x squared plus y equals 7. Because there's no y's, I've seen some people, they'll put a plus 0y and a plus 0y squared. You can put a little placeholder if you want. If that helps you to add up your like terms, go ahead and do that. Now when we do that and we combine these, we get 2y squared plus y equals 19, or 2y squared plus y minus 19 equals 0. Now, if you do the quadratic formula to this equation, you get negative b plus or minus the square root of b squared minus 4ac. I did that earlier. I got 153. All over 2a's, or 4. Okay. Now, just so that we have some numbers to deal with, if you put into the calculator, if I can find my calculator, if you put into the calculator negative 1 plus the square root of 153 over 4, you get, I'm just going to round it for this purposes so I can kind of show you what happens. You get 2.8, or you get a negative 3.1. Okay. Now, I need to find the y value that matches that, okay? So it doesn't matter which equation, I'll just do x squared plus y squared equals 6. If you put in 2.8 for our x, 2.8 squared is 7.84. So when you solve this, you have to take 6 minus 7.84, which is a negative number. Can you square a number and equal a negative? Can you square a number and make it equal a negative number? No. Can you take the square root of a negative number and get a real number out? No. So however you do it, if you get at this point and look at it and go, oh, that doesn't work. Or if you try to take a square root of a negative, oh, that doesn't work. That one just doesn't work. Now, if we do the same exact trick for the 3.1, 3.1 squared is 9.61. We get that y squared is negative 3.61 again. We get another negative. So it just doesn't work. It just isn't a thing. So this one has no solution. Now, how does this appear when we actually put it into Desmos? Well, if we put it, that's not what I want. We can read a book together, but Anyway, if we put it into Desmos, we can find that the parabola and the circle just do not have a point of intersection. So let me show you. So our circle, I believe, kind of is just too small of a radius, and our other parabola is just too high, that they just don't meet up. So expect that you have to be very careful about what you're dealing with. Am I dealing with, am I trying to take the square root of a negative? And so if we look at this, see what happens? The parabola is so high that it never touches the circle. And so that's why number 6, there is no solution. Okay. Do we have any questions about 1, 5, or 6? Okay. So for the remainder of class, please finish this. Okay. If you missed the video on Friday, there's a similar video from Friday. This is due by the end of class. Okay. So do your things.